Hi everyone, welcome to this geometry tutorial video. Today we'll be talking about applying the properties of similar triangles. So go ahead and open your textbook to Chapter 7, Section 4, and take notes and examples down as you follow along with the video. So let's start with this picture. We're told that line EF is parallel to BC, and what we want to do is solve for x. So let's go ahead and set the problem like this. I'm going to say that since these two segments, this line and the segment, are parallel, I know that angle B is congruent to angle AEF by the corresponding angles postulate. I also know that angle C is congruent to angle AFE by the corresponding angles postulate, and that is enough information to tell that these two triangles are similar. So let's go ahead and set up a proportion to solve for x. And what I'm going to do is do something a little bit differently. I'm going to split up the segment, so I'm going to say that AE plus EB, which is essentially AB, over AE. Those are my corresponding sides of the triangle, equals AF plus FC over AF. Okay, so why did I do this? What I want to show is that I can actually simplify this proportion down to something that's going to be a little bit more useful and maybe even a shortcut. So what I'm going to do is go ahead and split up the numerator into two separate fractions. Okay, so that's just this ratio split into two different fractions, and that's equal to the second ratio. I'm going to split that also into two different fractions, AF over AF plus FC over AF. Okay, so let's see what we can simplify. We can simplify AE over AE. That just equals 1 plus EB over AE equals AF over AF. That's also 1 plus FC over AF. Okay, well the great thing is that the 1's cancel. I'm just left with this proportion. EB over AE equals FC over AF. Okay, so that's actually going to make this problem a little bit easier. Well, let's go ahead and plug in our values for each of these segments. So EB, I'm going to start over here. EB equals 6 over AE equals 3. So we know that's going to reduce to 2. And this will be equal to FC, which is x, over 2. So when we cross multiply and divide, x equals 4. Okay, great. So this idea of simplifying the proportion down to these two ratios, triangle proportionality theorem. So whenever we're given a triangle that a parallel line intersects two sides of the triangle, the line is parallel to one side, we can conclude that the parallel line divides those two sides proportionately, and that's what we're given right here. So that is the triangle proportionality theorem. So let's go ahead and look at a picture. What we're told is that line EF is dividing side AB and side AC proportionally. That's where we're getting this proportion right here. And so what that means, what we just discussed, is that triangle AEF is similar to triangle ABC. Okay, so what can we conclude from that? Let's go ahead and see. I'm going to erase this. See, we can conclude. So if those two triangles are similar, then I know that angle B is congruent to angle AEF. I also know that angle C is congruent to angle AFE. And by the converse of the corresponding angles postulate, I know that line EF is parallel to side BC. Okay, it's the converse of the triangle proportionality theorem. It just says that if I have a line that divides two sides of a triangle proportionately, then I know that that line is parallel to the third side. So, an example just to apply this idea. We want to verify that side KL is parallel to segment MN. So how we're going to do that is prove that segment MN divides the two sides of the triangle proportionally. So we're going to set up two ratios. We're going to say that Jm over mk. And we're going to plug values in just a second, but we're going to compare that to a second ratio, Jn over nl. Let's go ahead and plug values in. So Jm is 42, and mk is 21. Then Jn is 30, and nl is 15. So both those ratios reduce down to 2, which is obviously equal to itself, and we know now that the two segments are parallel to each other. So let's use these two ideas to help us solve this problem. Before we begin, let's plan a little bit. I'm going to draw a line connecting point B to point E. And it's going to go through this other point, point X. Okay, and what we can gather from the picture is that line AB, line CD, and line EF are all parallel to each other. And then we have transversals AE and transversal BF. What we want to do is solve for X. Okay, so I just drew a third transversal, BE, with point X on that line. So now we have our two sets of similar triangles, and our sets of similar triangles are right here. We have triangle BXD is similar to triangle BEF. So using the triangle proportionality theorem, let's go ahead and set up our proportions so that we can compare the sides. I have BD over DF equals BX over XE. Okay, then we have another set of similar triangles. They're upside down, a little bit harder to see, but they are still here. So we have triangle EXC is similar to triangle EBA. And by the triangle proportionality theorem, we can also create a proportion between these two triangles. Now let's go ahead and do that. We have AC over CE equals BX over XE. The great thing about this is we have a common ratio between these two proportions. So, by the transitive property, I can say that BD over DF equals AC over CE. And that's going to be really helpful when we solve for X. So let's go ahead and do that. We have enough information and we have the setup we need to solve for X. So BD is X minus 3 over DF is X, and AC is 4, and CE is 5. So when we cross multiply and divide, we have X equals 15. So this idea comes from the proportionality theorem. So it's a corollary, it comes from it, and it's called the true transversal proportionality. What that means, what that says is, if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So we have our hypothesis here, which is exactly what we just looked at, and what we saw was that they do indeed divide the transversals proportionally. And look at one last thing. So we're given this figure, and it shows us that angle A is bisected by segment AD, and we want to prove that BD over DC is proportional to AB over AC. And what we're going to do is combine the things that we've just looked at, the triangle proportionality theorem, and work up to getting to this idea right here. Okay, so let's plan this out a little bit. I'm going to add a few segments. I'm going to extend side AC to the exterior of the triangle, and where it ends is going to be point X. And then I'm going to redraw. I'm going to draw another segment, X back to, there we go, point B. I'm going to actually just make this a solid line to help us out. Okay, but both those are exterior to the triangle, ACB. And what these segments are here to do is just to help us get to the idea, get to prove that these two ratios are proportional. So I'm going to say that XB is parallel to AD. So I'm going to say that I've drawn XB so it is parallel to AD. Well, using the triangle proportionality theorem, I can say that BD over DC is proportional to XA over AC. And the reason I can say that is we have these two similar triangles. We have CAD and CXB. So they're kind of on their sides. So using the triangle proportionality theorem, we can get to this proportion. Okay, so we know that XB and AD are parallel segments. So we know that angle CAD, so this angle right here, is corresponding to AXB, and since these segments are parallel, they're congruent. The angles are congruent to each other. Okay, well, they're corresponding and so therefore congruent. And then we have angle DAB right here, and that is an alternate interior angle to angle ABX, which is right here. Okay, so there's a couple of things that we need to look at in this picture now. By the converse of the isosceles triangle theorem, I know that AB, side AB, has to be congruent to side XA. So that's the converse of the isosceles triangle theorem. And what happens next, I think, is pretty neat. So we have XA right here, and since it is congruent or equal in length to AB, I can just replace XA with AB. So I'll rewrite the proportion this way: BD over DC equals AB over AC. And we've got the proportion that we had wanted to prove. So this idea is angle bisector theorem. It says an angle bisector of a triangle divides the opposite side into two segments. So we have BD and DC, whose lengths are proportional to the lengths of the other two sides, to AB and to AC, which is the proportion we just proved a second ago. So let's apply this idea. We have this triangle SRT, and we have an angle bisector. Angle S is bisected by segment SV. So we can use the triangle angle bisector theorem to set up the problem, solve for x, and then plug x back in to solve for the lengths of RV and VT. So let's go ahead and do that. We have RV over VT is proportionate to RS over ST by the triangle angle bisector theorem. So let's go ahead and plug in the lengths for each of these segments. So RV is x plus 2, VT is 2x plus 1, and that is equal to RS is 10, and ST is 14. So before we go forward, I'm going to go ahead and simplify this fraction right here. I can reduce this to 5 over 7, and I encourage you to do that anytime you have a fraction that can be reduced. It'll make it easier to cross multiply and divide. So we have now x plus 2 over 2x plus 1 equals 5 over 7. So when we cross multiply, we have 7x plus 14 equals 10x plus 5. That's 5. So when we combine like terms, we get x equals 3. Great. So when we plug x back in, we get RV equals 5 and VT equals 7, which makes sense. If we were to go back to this ratio, we would get 5 over 7, which is the exact ratio we got right here. So let's review. We talked about the triangle proportionality theorem and the converse of that theorem. The corollary to that theorem, the two transversal proportionality theorem, and the triangle angle bisector theorem. All these theorems kind of lead up to this last one, the triangle angle bisector theorem. Now I encourage you, if you have any questions, go ahead and go back to a part in the video that you have a question about and rewatch it and try to see if you can answer your own question. Thanks.